This is question 10 from Worksheet 10 from the second learning outcome on integration from Math for Engineering 3. In this question, we're looking at an application to integration style question, finding the length of a curve. And we're given a formula for doing this in the formula sheet for the unit, and it relies on us finding the derivative of the formula for the length, for the curve that we're finding the length of. So we want to find dy by dx here. That's going to be equivalent to f dash x that we need for the formula. And the best way to do this is to use the chain rule. So we're going to say that y is equal to 1/3. And of course, x squared plus 2 cubed square rooted is the same as x squared plus 2 to the power 3 over 2. And we're going to say u is equal to x squared plus 2. So that means we can write y is equal to u to the power 3 over 2 over 3, and dy by du is equal to 3 over 2 times u to the power a half over 3, which is the same as u to the power a half all over 2. Then to find du by dx. Du by dx is equal to 2x. To find dy by dx, dy by dx is equal to u to the power a half over 2 times 2x, which means we're going to substitute in our value for u, which means we've got the square root of x squared plus 2 over 2 times 2x, giving us x times the square root of x squared plus 2. So those 2's at the top and bottom cancel out. So we now have our expression for dy by dx, or f dash of x. So we can now enter this into the formula for the length of the arc. We've been told our limits are 3 and 0, and the formula says the 1 plus the term we've just worked out, x times square root of x squared plus 2, all squared. So we'll start to expand out and tidy up from here. This gives us, squaring that bracket, we're going to have x squared times x squared plus 2. Include my dx's, of course. That's equal to, we'll have 1 plus 2x squared plus x to the power 4 dx. It might not appear obvious where to go from here, and we wouldn't in this unit attempt to integrate something like this directly, a polynomial of degree 4 inside a bracket to the power half. We don't need to, but we need to make an observation about how we can factorize this polynomial. If we recognize that 1 plus 2x squared plus x to the 4 is the same as x squared plus 1 all squared, then our next line of the square root of a squared bracket is going to give us the integral between 3 and 0 of x squared plus 1 dx. And that's the trick in this question, is to spot that, because everything else we follow the procedure, we know how to do chain rule and use our formula for the length of the curve. We have to spot this factorization of the polynomial into a squared term that can then be removed by taking the square root. So integrating this, we're going to have x cubed over 3 plus x between limits of 3 and 0, and that's going to give us 3 cubed over 3 plus 3 minus 0 cubed over 3 plus 0. So that second bracket is going to be 0, and that means, well, 3 cubed is 27, divided by 3 is 9, so 9 plus 3 is equal to 12. And remember, this is a length, so we should say 12 units. And that concludes the question.